Hey everyone, welcome back to the part 5 video on open source LLM RAG series using Langchain and HuggingFace. In this video, we will dive deep into Qdrant, which is a vector store to save your embeddings. So far, in our previous video, we have used ChromaDB and FAS as our vector store. But here, for a change, we will look into different vector store, and mainly we will look into two different approaches. The first approach will be Qdrant Cloud, and the second approach is Qdrant In Memory. So let's quickly get started with this video. Before we begin, we need to set up few credentials. And if you are following this video series, you know we have to use HuggingFace access token so that we can make use of open source LLM using HuggingFace app and also HuggingFace embeddings using a access token. Now, in order to get your Qdrant Cloud cluster URL and also Qdrant key, we need to go to cloud.qdrant.io. Once you enter this website, there are different options. So this is your cloud dashboard for Qdrant. You can just click on clusters and create a new cluster. You need to give a name. So in my case, I'll just write RAG open source LLM. And once I write any name, I need to select my cloud provider and as well as region. I will go with default one and I will create my new cluster, which is free. It's gonna take just 1 or 2 seconds to create your own cluster. And once you create your cluster, you need two things now. The first thing is API key. The second one is endpoint URL. So click on API keys, create a new key. You need to select the cluster name, click OK. And as you can see here, you're able to get your key. First, let's copy this key so that it doesn't get vanished. I'll come back to my home page. I will just create Qdrant key and I will save it here. So this is not required. I'll just remove this. So this is my key and I also need Qdrant URL. So let's get the URL. And as you can see, this is our URL, which is some random words followed by region name, which is US East 4, and followed by our cloud provider, which is GCP Cloud. Just copy this link along with cloud.qdrant.io 6333, which is the port name. We need to copy this entire thing, copy, paste. So this is our Qdrant key and Qdrant URL. And in our case, we will build the application of chat with web page. So let's quickly write the import statements as well. So we have set up the keys. Now we need to import few statements from Langchain. So let me download Langchain rather than Langchain community. So I'll do pip install Langchain and I will run this cell. Here, I need my LLM model. That's where I'll write from Langchain community dot LLMs import HuggingFace up. And then I need my document from Langchain document loader. It should be community dot document loaders import. Since I need to chat with website, it should be web-based loader. And next step is you need to create chunking. And in order to create chunk, I'll use from Langchain dot text splitters. I'll just wait for a few seconds for auto completion. Text splitter import recursive. It should be recursive character text splitter. Now I need my embedding, and in order to get my embeddings, again I'll use community embeddings import HuggingFace inference API embeddings. And lastly, for the first step, we need the vector store. And the vector store in our case is Qdrant. Vector stores, import Qdrant, and we need chains. Rather than chain, we'll be using Langchain expression language. We covered Langchain expression language in the part 2 of the video. You can check out the description for the links. Let's quickly run our import statement. We'll start with the code part. We need our data. Now data is our web base loader. You need to pass your URL name. You need to pass your website URL. And then you need to load your documents. Load your data documents. So as you can see, this particular website is the article that I wrote on Gemini and Llama Index. So this is the content, which is also available on my Medium page. You can read it out and you can test out how you can use Gemini. How you can use Gemini along with Llama Index. It's a really very good model, which helps you with multimodal, add any image you want, and you can ask any questions related to it. So I'll take this URL of my article and let's see what is getting extracted. I'll do print docs. So as you can, let me print the page content instead so that it will be clearly visible to everyone. Page content inside my document. And as you can see, you are able to see multimodal using Gemini and Llama Index by Tarun Jain. And I have my entire article over here. If you want to see the entire thing, I'll remove the print statement. So this is the complete article. All right. So now what we need to do is, it's a lot of text. We need to create chunk of it. Let's create chunking of it. And in order to create chunk, you need to split the data. You can split your data using recursive character splitter. Add your chunk size. Chunk size is, I'll just use it as 512, and chunk overlap to be 50. And how chunk overlap is assigned, you can watch my part 1 of open source rack series. You will understand what chunk overlap is and how it is very useful. For time being, we'll just split our data and we need to create chunks of it. Text split dot split documents, and here I need to pass my documents, which is docs. And let me check what is the chunk size total, how many chunks I have. I have total 12 chunks. Each chunks contains around 512 chunk size, which is your token length. Let's quickly proceed with the embeddings. Our embeddings is the HuggingFace access token. All the HuggingFace access token that we are using, it doesn't need, we need to load the model. Suppose if you want to use any embedding model from HuggingFace, it will first load the content of it. In order to avoid the loading time, we directly use access token. So here we will be using HuggingFace inference API embeddings. And you need to pass two things. The first thing is the API key. And our API key is nothing but HF token. Copy this, paste it here. And then you can name any model name that you need. Model name equals to BAAI / BGE base EN v1.5. So this is one of the models that I oftenly use. If not, you can also use the NLPR / GTE large. So you can pick any embedding model that you of your choice. The one thing what you need to do is always whenever you use any open source embedding model or open source large language model, it's better to check out the leaderboard, because the leaderboard is getting updated very frequently and there are new models getting released every single month. So check out that leaderboard, get the model of your choice, which is performing better. In our case, we are just using the inference API along with API key and the model name. Now what you need to do is, this is where Qdrant comes in. We have created the chunk of our data. We have created the embeddings. Now what we need to do is, we didn't create embedding, rather we just initialize the embedding and we have the chunk of it. You need to combine your chunk and embedding and it will save in a vector store. So what you need to do is create a vector store. There are two ways we'll do it. The first way is cloud. The first way is using cloud. I'll just write vector store for cloud. And how you need to define is Qdrant from documents. You need to pass your chunks, which is your data. And then you need to provide your embeddings. What you need to do is, this is the common approach. Whenever you need to use a vector store, you need your document, you need your embedding. Now, this will create the embeddings and store it. But what do we need here? We need the cloud data as well. So you need to write URL. Now, what is our URL? URL is nothing but Qdrant URL. And you also need API key. API key equals to, it is Qdrant key. Copy this, paste it here. And finally, you need collection name. Why collection name is required? There are multiple ways where you will add your data. Now, let's suppose if I add my data, it will create the indexing of it. If you want to store this index and then reuse it, this is where you can use collection name. So in my case, I'll just use the collection name to be RAG. I'll just write RAG website. This is it. So now what this will do is, it will take all my chunk, it will create the embeddings of it, and it will store in the vector store. This vector store is hosted on Qdrant Cloud. That's where you need to provide the URL and the key of it, followed by a collection name. So now you can do the search technique. I'll do a search. I'll just write vector store dot similarity search. I'll check for the auto completion. Sorry, it is vector store dot similarity search. Let me wait for some time so that I get the auto completion. It's not giving me any auto completion, but that is fine. It gave me. So vector store dot similarity search, enter any prompt that you need. I'll just write, let me check. All right, I'll just write what Gemini model is used in the blog article. So this is my query. Based on this query, I need to do search and get the relevant document. And then I will just print search. So as you can see, it is generating few documents. And in my first document, you can see AI, large language LLMs are the forefront of innovation in today's rapidly world. It has given me the data related to Gemini. In my second document, again, it is giving me wherever Gemini is mentioned. So what it will do is, it is doing the keyword search and it will generate wherever Gemini is used. But if you look carefully, right, if you look carefully here, in this article, we will implement multimodal use case basic example using Gemini provision. So you have the model name in the first document itself. So all these documents later on will be passed to your LLM model. So far our vector store is working. So this is the proof that whatever storage we have done in the cloud, it's working. You can also refresh your cloud page and check the usage of it. I'll click on cluster. The collection name should be visible here. As you can see, there is certain usage that we have done and the RAM was used and also some disk space has been utilized. So this is the sign that we have successfully used Qdrant Cloud. Moving on, we will look into the second approach. The second approach is most of the people uses, which is in memory. Let me create a new heading, in memory. And this was cloud. And in memory, we don't need cloud URL or cloud API key. We just have to add the persist directory. And if you don't know what persist directory is, you need to watch part 4. Part 4 and part 3 also uses persist directory. So you can check out those articles. Now what I'll do is I'll create a new vector store. Now I'll name it as vector DB because I've already named it as vector store. Here I'll name it as vector DB. Same thing. You need Qdrant from documents. You need chunk and embedding. You need chunks and embedding. And apart from that, you also need the path, which is your persist directory. You can name it as DB. And again, you need to write collection name. The collection name will be, what should I name it? I'll just name Gemini. And that's it. This is it that you need to do. One is you need to pass your document. One more is you need to pass your embedding, then the path of it along with a collection name. Just run this code and you're able to create your vector store. You're able to store your embeddings. Now what you need to do is copy this search, paste it here. Sorry, I didn't copy it properly. Copy this, paste it, and instead of vector store, I'll just copy it and I'll make it vector DB. I'll ask the same prompt, same query, and I'll run it. And as you can see, again, it is giving me few responses, which is good. Okay, it is giving me related to Gemini, which is good. So this is the proof that even my vector DB is working and even my vector store is working. So let's proceed and connect our retriever to the generator. So far, we only have vector store. We don't have retriever. So how we can use retriever is, you can just use vector store as your retriever. My retriever is equal to, I'll be using vector DB, which is my local path. Vector DB as my retriever. As let me check the option. Here it is. My vector DB dot as retriever. Here you need to define your what search technique you need to use. My search type will be MMR, and I also need to define my K size. As you can see, there are so much documents which is getting retrieved. Let me rerun this. And if you check my search, there are so much documents which is getting retrieved. But for a small document, you don't need so many K values. That's where you need to update your K values. What I'll do is I'll use search keyword arguments equals to K colon. I just need 2 and I will run this. Now let's use the same thing. I'll do retriever dot get relevant documents and I will pass the same query which I asked earlier. And the query is what Gemini model is used in the blog article. I'll paste this. So retriever will only do the search and it will return you the context. It won't generate the response. In order to generate the response, you need a LLM, which adds the intelligence of it. So let's add LLM. LLM equals to HuggingFace hub. Here you need to provide the repository ID. The repository ID is Zephyr model. So let me quickly copy. Wait, let me check the model name. It is HuggingFace. It should be HuggingFace H4. H4 is the repository ID name, and the name of the model is Zephyr 7 billion alpha. So this is my model name, and my API key is already saved. My API key is already saved in the environment variable, so I don't need to recreate it. So let's use the same API key, but since it is already in environment variable, HuggingFace Hub will take it from there. Here you also need to define model keyword arguments. Very, very, very important. You need to decide what model keyword arguments you need to give. What happens in open source LLM is your prompt, whatever you ask, and the response, whatever you get, it is merged and it is generated in the response. But in the response, we don't need the prompt. That's where you need to define all those things in the keyword arguments. So let me quickly write temperature. Temperature is to avoid the randomness. So I'll just use temperature to be 0.1. And I need my maximum new tokens. So what this parameter do is, whatever response you have, I need certain limit in it. Okay, if you just give 10, you will only get 10 words. If you give 500 or something, you will get a very lengthy response, and you need to have certain maximum value. Okay, if you ask a simple question, what model it is, your ChatGPT or model, which is Zephyr, it will give you Gemini Pro Vision. So it will maximally utilize 40. But if you tell to summarize my blog, it might take around 500 to 600 words. That's where you need to have certain threshold limit for your maximum value. That's where you need to assign max new tokens. And my maximum will be 512, which is the standard size. And you also need to write return full text to be false. So what this will do is, whatever prompt you have, it won't be added in the response. So you can avoid the prompt addition in your final response. So these are the three main arguments that you need to add. All right. So RAG is mainly about retriever and generator. We have our retriever. We also have our generator. We need to combine them using a chain. But there is a missing part here. The missing part is the prompt template. So what is RAG? Retrieval augmented generation. We have the retriever, we have the generator, but augmentation of the prompt is still missing. So let's quickly write the prompt. Let me quickly write the prompt. First, you need to define your system prompt. So I've already written it. I'll just copy it from here. System, you are an AI assistant that follows instructions extremely well. Please be truthful and give direct answers. So this is my system prompt. I will close my system prompt. And once I close my system prompt, I also need to define my user prompt. So user prompt is the query that user will write. And let me quickly define the query as well. Let me define the query. My query is what Gemini model is used in the blog. Copy, paste. This becomes my query, and this again becomes my user prompt. And now you also need to close your user prompt. And finally, you need to tell your LLM model to generate the response. You have system, you have user, then you need your LLM, which is your assistant. ASSIST. All right, so this is my prompt template. Now what I need to do is I need to run my response. And in order to run this, you can use a retrieval QA chain. So let me quickly write from Langchain community dot chains. Let me check if it is from Langchain community. No, it is from Langchain dot chains. Import retrieval QA. Now what you need to do is you need to pass your prompt retriever and your LLM model to the chain. So in order to do that, I'll just define QA retrieval QA dot from chain type. From chain type, you need to define your model name, which is your LLM, and then you need to define the chain type. Chain type can be stuff, and then you need to define your retriever, which is your retriever. And once you define your chain, you need to add your augmented prompt. Response equals to QA dot run the prompt that you have used here. And then you can click to generate your response. It's gonna take few seconds. As you can see, it took just 3 seconds. I'll print my response. The Gemini model mentioned in the blog article is a cutting edge. Let me remove this print statement so that I don't have to scroll. Gemini model mentioned in the blog article is the cutting edge technology developed by Google DeepMind. It is a multimodal AI model. So this is what is very necessary. You need to mention multimodal, but I need the name of it. I'll just ask what LLM model is used, or let me ask one more question. What is LLM framework used in the blog? LLM framework used in the blog. So you can ask whatever questions you need, but the only main motivation for this video was how you can use different vector database such as Qdrant or VV8. The approach is same. The approach is same for whatever vector database you use. The only thing is you need to create your URL and your API key if you are using cloud service. If you are using in memory, then you just need to provide the path of it along with a collection name. And let's see what response we got. The blog does not specify specific LLM model framework used. Blog post is discussing the use of Llama index. So as you can see, our model has given the response. It has told Llama index was used, which is exactly the same thing I wanted. Okay, so the LLM framework which was used is Llama index. I might not have specifically used a keyword like LLM framework in the blog, but still my model was very intelligent enough to understand what framework was used in the blog article. So this is it from part 5 video. We will probably release few more videos in this particular series, whether it is related to memory, addition in the Langchain, or anything else. So until then, do subscribe and like this video so that it will motivate me to add more videos. Thank you so much.